This is the two-way ANOVA video on adjustment and control. In the two-way ANOVA, we've labeled the two categorically scaled predictor variables as factor A and factor B. Suppose these factors are not of equal importance to you, and that factor A is relatively more important, factor B relatively less so. For example, in a study of post-stroke rehabilitation, with the outcome being functional status at the end of rehab, the rehabilitation method would be factor A, whereas the level of stroke severity would be factor B. Stroke severity is important because it's strongly related to outcome, but it isn't important to you as determining which rehabilitation method is better. In this case, stroke severity is called a covariate, and we say that the two-way ANOVA controls for, or adjusts for, stroke severity. In general, you'd like your models to have as few predictors as possible, so you shouldn't try to control for everything. This slide provides some reasonable criteria for deciding whether to include a covariate in a model. You should almost always do so if the covariate explains an important amount of variation in the outcome. If the design is balanced, as would be the case for a randomized trial, including the covariate will increase the precision of the analysis and its associated statistical power. Thus, the rationale is precision and not bias. On the other hand, if the design is unbalanced, as is often the case for observational studies, the primary reason to include the covariate is to eliminate the bias that would result from its omission. One of the class exercises will walk you through this issue in depth. In the stroke example, balance means that different rehabilitation methods have similar distributions of stroke severity. Analysts often tend to be more liberal in adding covariates when the rationale for doing so is based on bias rather than precision. This saves your audience having to worry about whether your results would have been substantively different if the covariate in question had been included. Sample size also plays a part in this decision. You pay a greater statistical price for it when adding covariates to small studies than you would if the study were larger. Returning to the argument about precision, including factor B as a covariate increases precision because including in the model would decrease the sum of squares for error, thus will almost always decrease the mean square error. Please recall that the mean square error represents the amount of noise in the system used in statistical testing. Standard error of the model parameters are based on, among others, this mean squared error. To illustrate bias, this slide walks you through the argument in the previous stroke rehabilitation example. If patients with very severe strokes tend to receive a certain method of rehabilitation, that method will tend to generate worse outcomes unless severity is included in the two-way ANOVA model as a covariate. What else might you wish to include as a variable as a covariate? One thing you might want to include is study design. For example, suppose that you originally thought that something was important enough to be a stratification factor. In that case, stratifying by the factor in question will ensure that your groups will be more or less balanced on this factor. And you should probably include the factor in the model even if it doesn't turn out to make a difference in outcome. The principle that you'd be following is to match the study analysis with the study design, which based the randomization stratification on that variable. Another reason to include a variable as a covariate is that it was a major part of your analytical framework. For example, if the literature says a variable is likely to be important, and your study you should probably include that factor in the model, even if it doesn't turn out to be important. The principle that you'd be following is to match the study analysis with your analytical framework. It will also serve to reassure your audience, who are probably expecting you to control for that variable. All of the previous decisions about whether to include a variable in the model are taken on a case-by-case basis, and reasonable people might differ about any particular decision. One case about which there is no debate, however, occurs when your covariate is intermediate in the causal pathway between the primary predictor and the outcome. Don't include these potential covariates in your model. Here's an example of what you're trying to avoid. If a particular statin works by reducing total cholesterol, then you shouldn't control for cholesterol, as doing so would make the impact of the statin artificially disappear.